Hello, good evening. This is Dr. Karthik, and in today's lecture series in control system, we are going to discuss the topic regarding signal flow graph. So the previous topic what we have discussed is the block diagram representation, which is again graphical, that is, it is a pictorial representation of the mathematical representation of the systems. Now in the same way, signal flow graph is also a pictorial representation, which is in terms of graphs, that is a graphical representation of the algebraic equations. Now the block diagram reduction what we have seen earlier, now it takes more time if the system complexity increases. So reducing the block diagram for a big system, it takes a lot of time and it is a big complicated process. So in order to overcome the drawback of the block diagram reduction technique, now we just move in with the next technique, which is called as the signal flow graph, where the transfer function is found by using a standard formula called as the Mason's gain formula without any reduction process what we have seen earlier in the block diagram reduction. So the basic elements of the signal flow graph is the first one is the input node. So now the above diagram, which is nothing but it is the basic graph of a system, and it represents now y1, it represents the input of the system, and y4 represents the output signal. And now you can see the signal flow is unidirectional, and there are various elements of this graph, that is, this represents the algebraic equations. Now in which the first terminology is nothing but it is the input node. It is the node which has only outgoing branches. So you can see now this y1, that's the input what already we have discussed. Now you can see this node is having only the outgoing branches. It doesn't have any signal which is coming into the node. So therefore this y1 is called as the input node. Similarly, the output node, so y4 is the output node which has only incoming branches. Now you can see the signal to this node y4, it is only incoming towards y4. So therefore this node which has only incoming branches is called as the output node. And then the next one is the branch. It is nothing but the line segments which is joining two nodes. So here y1 and y2, there is a line which joins y1 and y2. So this A, now this you call it as a branch. Now it has both gain and direction. So A is nothing but the gain acquired by the signal to move from node y1 to y2. And this represents the direction in which the signal flows. So A is the gain and the arrow mark represents the direction in which the signal flows. And the next terminology is nothing but the open path. So it is nothing but it starts, that is, it is the path which starts at one node and ends at another node. That's it. It starts at one node and it ends at another node. So each node it travels only once. So you call it as a open path. Now what is a forward path? Forward path, that's the next terminology. Now it is the path from the input node to an output node and which does not cross the node more than once. So you can see y1 is the input node, y4 is the output node. Now the signal has to travel from input node to output node, but it has to cross all the node only once. You call that as the forward path. Now next, it is the individual loop, that is, we can simply say it as a loop. It is a closed path and it starts from one node, and after passing through several nodes, it has to arrive at the same node, and each node it will cross only once. Now I'll just mark in the diagram. Now I can see now this signal, now it starts from y2, it moves to y3, it come back again to y2. So each node it is crossing only once. Now this you call it as a loop, or you can call it as a closed path. It has to travel or it has to cross each node only once. And then it is non-touching loops. So if a loop does not have any common node, then you call that as a non-touching loops. For example, now if the signal is extended say up till y5, and we have a loop in this case, say this is minus e. Now in this case, now this is one loop, This is the second loop. Now these two loops, they don't have any common nodes. So therefore these two loops are called as a combination of one non-touching loops. So that is loops which does not have any common nodes. You call it as a non-touching loops. So these are few terminologies or the basic elements of a signal flow graph. Now again you can see, now this is nothing but the basic elements of the block diagram which already we have seen. Now the Mason's gain formula, now this is the formula which we use in order, that is to find the transfer function of any system. Now T, that's the transfer function, it is C of S by R of S is equal to summation n is equal to I is, that is summation I is equal to 1 to n Pi delta I divided by delta. Now where C of S, it represents the output node, R of S which represents the input node, T is the transfer function of the system, and Pi over here, it represents the forward path gain. Okay, so it is the forward path. So this I is nothing but the number of forward paths. So this we will discuss while we are solving the problems. And delta, it is nothing but 1 minus sum of all individual loop gains plus sum of gain products of all possible 2 non-touching loops, 3 non-touching loops, etc. So already we have discussed what is the individual loop, what is 2 non-touching loop, already we have discussed. So delta is nothing but 1 minus sum of all individual loop gains plus sum of the gain product of all possible 2 non-touching loop, 3 non-touching loops, it just keeps on going. And delta I, it is nothing but delta for the ith path. Delta for the ith path. So that is nothing but your delta I. So this formula, you call it as the Mason's gain formula, a straightforward formula in order to identify the transfer function of a system. So unlike a block diagram reduction where we have certain rules and there is no, that is which rule has to be applied first, we don't have any definite methodology, but here in this case we have one formula. Based on this formula the transfer function will be identified. So the signal flow graph is much easier methodology or the pictorial representation or graphical representation in order to find the transfer function rather than the block diagram reduction. So therefore if we have any block diagram, how to convert the block diagram into a signal flow graph. So that is the next thing what we are going to discuss, that is converting a block diagram into a signal flow graph. Now what are these steps? Now the first one is represent all signals, variables, summing points, takeoff points of the block diagram as nodes. Which one to represent as nodes? The signals, the variables, the summing points and the takeoff points. Now all these are represented as nodes. Then represents the blocks of the block diagram as the branches in the signal flow graph. The blocks, now it will be represented as branches. So the block, inside the block we will have the gain, so they will represent the gain of the branches. That is the transfer function inside the block diagram will be represented as gain of the branches. Now once everything is represented, now we are going to connect all the nodes as per the block diagram. We will connect all the nodes as the block diagram, and if there is a connection between two nodes but there is no block in between, then the gain of the branch is 1. So two blocks are connected but there is no any gain mentioned, now we have to take it as 1. Now these are the points to be remembered, or the steps to remember for converting a block diagram into a signal flow graph. So one such is being shown over here. Now you can see, now we have an input. Now we'll represent this as the input over here, and then you can see we have a summing point which will be represented as node y1, then the next summing point which is node y2, and then now we have two blocks connected, so we will go with as y3. And then you can see if there is a takeoff point which is going to be represented as y4, and then summing point y5, again a takeoff point or a take forward point which is y6, y7, y8 and y9, and finally the output. And each thing we have to represent as per the direction given by the signal. So this is how a block diagram is converted into a signal flow graph. So thank you for watching. Now the problem regarding the signal flow graph we will discuss in the upcoming series. Thank you very much.